Hi everyone, my name's Tim Kington and this is Java for Beginners. We have Daisy with us today to help out. Last time we talked about variables and data types, but we couldn't do anything terribly interesting with our data. Now we'd like to be able to do some calculations with it, so today we're going to talk about operators and expressions. Let's dig in. Okay, so here we have our basic starter Java project. Last time we talked about variables and how to assign values to them, so we could do something like this. We create an integer called x, and we assign it the value 23. We could also read input from the user and print it back out, but we couldn't really do any calculations with that data. So today we're going to look at how to do that. To do that, we're going to use operators. There are a bunch of different operators in the Java language. We're just going to look at the more common ones today, probably the most common 5 operators. So if we wanted to add some numbers together, we can just put a plus in our code. So 23 plus 4, say, and we can print out the answer here. And if we run this code, as you would expect, this is going to print 27. We have a subtraction operator, so we could put a minus in here, and obviously the answer is going to be 19. We can also multiply and divide. Multiplication is an asterisk. So 23 times 4 will give us 92, and we can divide with a slash. Now in this case, we start having to think about types a little bit. So we're using an integer x, so we cannot get a fraction in our result here. Since we're taking an integer, dividing it by an integer, we're going to get an integer result. And when we divide 23 by 4, what's going to happen is we will throw away the fractional part of that answer. So 23 divided by 4 is 5, and there's a remainder, but we just throw that away. The other operator that we have that is used pretty commonly, this actually comes up a lot in programming, but it's not one you've probably used in math very often, is modulus. So this is doing division, but it's going to return the remainder rather than the quotient. All right, so when we did 23 divided by 4, we really had 5 remainder 3. When we use the division operator, the slash, we're going to get the 5. If we use the modulus operator, we will get the remainder, which is 3. So those are the 5 arithmetic operators that are going to be used all the time in Java. There are others out there, but they don't come up nearly as often. And we could keep writing code like this and always printing out our results. But in real programs, you're not going to be printing things to the screen that often, and you still want to be able to see what's going on with your code. The way that that's done in the real world is using a tool called the debugger. So let's take a look at that. Let's first put some calculations in here. So maybe x equals 3 plus 5, and then we can say x equals 7 minus 1, and then x equals 2 times 4, and x equals 6 divided by 3, and x equals 5 mod 2, say. Right. Spaces, as I mentioned last time, don't actually matter to the compiler. I typically put spaces around my operators just to make the code easier to read, but the compiler will ignore those anyway. Really, any white space in a Java program is going to be ignored unless it's part of a string. All right, and now the compiler's unhappy because I'm not actually using x, so I'm doing all these calculations but never printing x out or doing anything useful with it. So at the end, let's go ahead and print it out just to get rid of that warning. So if I run this program, a bunch of calculations happen, and we can see at the end the result is 1. But we can't really see what's going on here in the middle of our program. Now this is kind of a silly, simple program. We're just overwriting x every time. So the only line that matters is the last one. But let's say that we were trying to figure out what's going on in the middle of this slightly more complicated code. We can set a breakpoint. So I'm going to click over here in the left margin, and that will add a breakpoint to my program. And what that's going to do is pause the program when we get to that point, and we'll be able to see what's going on inside it. So if I hit F5 to run my program again, this time the program will stop when it gets to this line, and it highlights the line. Now the line that's highlighted here is a line that has not yet executed. We are about to execute this line of code. And we're also going to get this debug toolbar that will appear, and it has a bunch of buttons on it. We have a continue button. If we click this, the program will continue to run normally until it hits another breakpoint or it completes. So if I run this right now, the program will just complete and print 1 out. So let's run it again. I have a stop button. That one's pretty obvious. And then we have these 3 step buttons. We have step over, step into, and step out. And we have a restart button. So restart will kill the program, start it again from the beginning. Step over is going to go through our code one line at a time. And whenever there's a call to a method, it's going to stay where we are. We're going to stay in this main method. Let me show you the difference between step into and step over here. The place we're going to see this is with this call to print line. So if we run our code and we pause at this point and we hit step over, it will print 1 and we move to the next line of code here. If instead, when we're at this point, we hit step into, we're going to go inside the code for print line. So this is some of the code that is in the Java library that knows how to print things on the screen. And we can go ahead and step through this and watch what it's doing if we want to. But usually we're not going to want to do this because we didn't write this code and we assume that it already works. So we can hit step out, which is the opposite of step in. So if we stepped into print line and then we want to get back out of that code, we can click step out and get back to where we came from. All right, so that's a little bit of basic navigation there. Let's put our breakpoint back up here at the top and then watch what happens as we run this code. So when we start the code, we're going to stop at this line. Over here we have a variables view, and it shows our local variables. We have a variable called args right now. That comes from this definition, but we're still not going to get into detail on that yet. If we hit step over once, this line of code ran. So we did this calculation, 3 plus 5. We stored the result in the variable x. And you can see over here in our local variable window that now we have a variable called x, and we can see that the value is 8. And then we can continue to step through our code a line at a time. And each time we do, the value of x is going to change. So x is now 6 because we did 7 minus 1. Then it will become 8. And you can see VS Code's actually being helpful in the code window as well. It's showing us the value of the variables that we're assigning in our code. So it knows that we assigned to x on this line, so it's just being helpful in showing us what x is. So if something weird was going on in our code and the calculation wasn't coming out the way we expected, then we could step through it like this line by line and see what's going on. And we'll be doing this a lot as our code gets more complicated. In this case, we did calculations only with constant values, which once again is not very interesting. But we can use variables in our expressions too. So here I could say x equals 3 plus 5, and then I could say y equals x times 4. And then I could use that value in a calculation. Z equals y minus 7. And then at the end, let's print out z. If we go ahead and run this, you can work out what's going to happen. Or we can just let the computer do it for us. It prints out 25. That must be the right answer. So 3 plus 5 was 8. Then we took 8 times 4. That's 32. And then we took 32 minus 7. And that gave us 25. And again, if we step through the code here, as this happens, we'll be able to see these variables appearing in our variable window. And VS Code's also going to show us the values over here on the right side of our code. So x was created with a value of 8. We step again. Now y is created with a value of 32. Step again. Z is created with a value of 25. And over here next to each of these lines, VS Code is showing us the values of the variables that are being used in that line of code. So we don't necessarily need to look over here at this values or variables window. We can actually see it right here in the code if we're looking for something obvious. Sometimes we'll have to go over here and dig around inside objects, look at more complicated data structures. But for now, these helpful little hints are all we need. We can also create more complicated expressions. So there's no reason we can't do something like this. We can put more than one operator into a line of code. What's going to happen here? Well, there's a question of order of operations, just like we have in math class. Are we going to do the addition first or the multiplication first? In Java, the rules are going to be basically the same as what you're used to from math. So multiplication and division are going to happen before addition and subtraction. So this will do 5 times 2, 10, and then add 3. So we're going to see a value of 13. And just like in math class, if we want to control the order of operations, we can add parentheses to our expression. So here we're saying do 3 plus 5 first, and then the multiplication, and that will be 8 times 2 and give us 16. Now, just like in math, we can make our expressions as complicated as we want. So we could say 12 plus this whole quantity, and then divide that by 2. Now again, the division is going to happen before the addition, and the parentheses will control the order of the rest of the calculation. We can run this, we'll get some answer, 20, and we could work through this by hand if we want to. So this would be 8 times 2 is 16, and then that's divided by 2 first, so we'll get 8, and then we're going to add 12, and we'll get 20. We're not often going to write complicated expressions like this with constants. This is really just an example of how we can put many operators into one expression. We can also do calculations with other data types. So let's use a double and give it a number. This time we can put a decimal part on the number because we're dealing with a double. And as you would expect, we can use the same operators with a double that we did with integers. So if we run this, we get 3.97, as you would expect. We can do multiplication, we can do division. All of the operators that we looked at for integers are going to work with doubles as well. We can also use addition with strings. So this is going to be a little bit different because we're not going to be performing a mathematical operation. The addition operator with strings is going to do concatenation. So it's going to basically glue our strings together, create one longer string from the pieces that we're adding together. Now this is kind of silly because we could have just written s equals hi there without any addition. But you can see what's happening here. We're adding the two strings together, and when we print out the result, we get the concatenation of those two strings. Now with a constant, we could have just written it like this in the first place. But what we really would have liked to do last time is ask the user for their name. So if you remember, we had a scanner that we created like this, and then we said string name equals in.next line. And we also had printed out what is your name, so the user would know what to enter. Well, now that we can use string concatenation, we can write a single print statement here and say hi, and then add on the person's name. And again, I have a warning because I'm not closing it in, so I'll go ahead and add that. So if we run this little program, what is your name? And now it prints hi Tim, which is nicer than what we were doing last time, right? Last time we were printing a string and then printing a value and writing a lot of extra lines of code. We really could have been doing this by concatenating strings and giving those to print line. Let's say that we would like to ask the user for their favorite number again, like we did last time. We could improve this code in the same way. So we'll say int num next int, and then we're going to print it out where number is, and then we'll add on num. Now this is going to do exactly what we would expect. So we put in a name, we put in a number, and it prints out our number. But there is something interesting happening here. Here we're adding a string to an integer, which we have not done before, right? We're combining two different types. Now it's pretty obvious what should happen in this case because you're reading the code and you have a sense of what it's trying to do. But the compiler can't figure things like that out. The compiler is going to have to follow a strict set of rules that it will follow every time when we combine different types. The rule for strings being combined with other types is that we will always convert the other type into a string and then concatenate the values. This can lead to unexpected results sometimes. So let's try something. We'll say, give me another number. And we'll read that from the user. And then we're going to print out the sum of the two numbers. And we'll say num plus num2 here. Okay. So we're going to add our numbers together and print them out. Enter some numbers. And that did not do what we wanted it to. So our total is 1, 2, 3, 4. Well, it shouldn't be, right? 12 plus 34 should give us 46. So what happened here? Well, this is where we have to be careful when we're combining different types with operators. So here we have a string. Here we have two integers. This calculation is going to take place from left to right. So Java is going to look at the order of operations. So it's going to do multiplication and division before addition and subtraction. But when operators have the same precedence, the calculation is going to be done from left to right. So here we're going to take this string and add it to num. The way that works is we turn num into the string version of the number, which is just the string 12 that you see on the screen here. And then that's going to get concatenated with the first string. So we'll have the total is :12. And then we're going to take that string and we're going to add it to this number. And again, when we're adding a string to a number, we will convert the number into a string and then we'll tack it on to the end of the first string. So we converted that to the string 34, and then we tacked it onto the end, and we got this string, which is not really what we were hoping for. Now this is happening because of the order that the operations are being performed. So we can fix this by adding parentheses here. Now we will add the two integers together first, and adding two numbers will give us a numeric result, and then we can put that number onto the end of our string. So if we run this now, you'll see that we get what we expected the first time. When we combine other data types, we're going to have similar issues. So we can say things like int x equals 2.3 times 7. Now here, we're combining a double and an int. And so the result is going to be the larger type in this case. 7 will get converted to a double, so it will become 7.0. And then the multiplication will happen, and the result will be a double. And since we're trying to assign a double to an integer variable, the compiler doesn't like that. It's telling us cannot convert from double to int. The reason is we would lose the decimal part of the number. So if we make this double x, then the compiler's happy, and we can print out this result. And we'll see we had a double result. Now you're going to notice this number is not exactly what you would have come up with on paper. In a computer, doubles are not represented exactly. So certain doubles will be represented exactly, like 2.5 can be represented exactly inside the computer. 2.3 cannot be represented exactly, and that means that when you do calculations with a number like that, your results are going to be a little bit off. We have to be a little bit careful with doubles because of that. I didn't really point it out before, but we were performing calculations in the middle of this print line statement, right? We had a string here, and then we had a number. It was a variable x at the time, but we could just add a constant in here as well. In Java, we can substitute an expression anywhere that the type of that expression is allowed. So we've talked about how variables have types, like int or double. Expressions also have types. When we say 3 plus 8, we're adding two ints, and the compiler knows that the result of that calculation is going to be an int. So this expression has the type int. And then when we assign it to x, the compiler's fine with that because the type of a variable that we're assigning to matches the type of the expression. If we create an expression that has a different type, then the compiler gets unhappy. Here we have two strings being added together, and that will create a larger string, which is then being assigned to the variable x. That's not going to work because x is an int. Printline is a little bit special. It can take pretty much any type we want. So we can really put any kind of calculation in here, and this will work. Let's do a string plus an int. So this calculation, the compiler is going to figure out that this will make a string. Whenever we add a string to something else, that other thing gets converted to a string and the two strings get concatenated. So this will be a string, and println can handle strings, so everything's fine. We can create as complicated an expression as we want here inside of our function call. And we'll get more into function calls a little bit later on. But here we can say something like x plus 3 minus 2. And then at the end, we could add a string to it. And we don't have x, so x is getting underlined. Let's go ahead and say x equals 17. And so we can print this out. We could really combine a bunch of code into a single line if we want to. We can have really complicated expressions and then pass those into calls to things like println. But it's going to make our code hard to read. And that's our second priority when we write code. Number one is get it to work. Number two is make it readable. You want it to be readable for other people, and you want it to be readable for you, because you will eventually come back and look at the code again in the future, and you won't remember what you were thinking when you wrote it. All right, let's write a program that we could not have written last time. We'll ask the user for two numbers, and then we'll print out the product. So we'll say double num is in.next double. If we want to read a double from the user, we're going to use the next double method. First, we should ask the user for the number, so we'll say enter a number. And then we'll ask for another number. We'll store that in a double as well. And then we'll print out the product of the two numbers. Actually, we can print it as a formula. So we can print num and then the times symbol. And then we'll print num2 and then an equals and then num times num2. There's something I'll point out here in a minute about this print statement. So let's enter some numbers, 1.23, 2.5. All right, it prints this out. 1.23 times 2.5 equals 3.075. This is the correct calculation. Notice that while spaces don't matter in our code, spaces inside strings do matter. So here I did not put spaces around this asterisk, and in the output, our numbers are right up against it. Here I put spaces around the equal sign, and in our output we have those spaces. So spaces inside of strings do matter, spaces in our code don't. So we can get rid of spaces like this, and this will not affect the execution of the program at all. It still runs, and it's still going to print the same result for us. So we can put in the same numbers and get exactly the same results. So spaces in the code normally don't matter. I do like to put spaces into these strings so that our output looks nice. When we run this now, we have, whoops, we have nicer spacing. When we print the result on the screen. All right, for next time, a small challenge for you. Try to write a program that will read 3 numbers from the user and print the average. Okay, there's a basic introduction to operators and expressions. Now we can read input from the user and actually do something with it. So we're moving forward. The programs we can write are getting more interesting each time. Daisy was not terribly excited about this topic. I hope you were more interested than that. Don't forget to like and subscribe, and I'll see you next time when we will talk about if statements.